Assalamualaikum warahmatullahi wabarakatuh. Honorable Mr. Nofri Suharmi, SSC MSc, as the lecturer of Statistical Machine Learning class, on this opportunity, we would like to present the results of our final project analysis titled Breast Cancer Classification Analysis using Support Vector Machine and Random Forest Algorithms. First of all, allow us to introduce the member of the group. I am Sabina Aisha Fidela with NRP 500321110 and my partner.
Muhammad Fikra from Exantra with NRP 500321108. Data shows that in 2020 there were 2.3 million new cases of breast cancer, and breast cancer remains one of the leading causes of cancer-related deaths worldwide. To detect the size of the tumor, imaging techniques such as ultrasound, mammography, and MRI are commonly used. This test can help predict whether the tumor is benign or malignant. One of the statistical methods used to predict whether a tumor is benign or malignant is by employing algorithms such as SVM and random forest. Based on the project background, the research problems are: what is the best machine learning model and what features can be used to predict the characteristics of breast cancer? And the research objectives to answer the research problem is obtain the best machine learning model to predict breast tumor characteristics and obtain features that can be used to predict breast tumor characteristics. In this analysis, we are using breast cancer data from Kaggle, which includes 32 variables and 569 observations. This and there is the link of the data. Next.
And next, we perform data preprocessing. First, we remove the ID column because this variable is not needed from the analysis. And then we check the duplicate data and missing values, and we found that there were no duplicates or missing values. After that, we check outliers using the IQR method, and we identify some outliers. So we replace the outliers value with the Q1 and Q3 values. And last, to make the analysis easier, we coded the target variable, which is diagnosis, where malignant is coded as 1 and benign as 0. And next, to understand the characteristic of the data, we conducted an analysis using descriptive statistics, and the results are as follows. First, mean features. The features with similar mean and median values, like radius mean and texture mean, indicate a symmetrical distribution, while features with a lower median than the mean, like perimeter mean and area mean, such as a right skewed distribution. And then the SA feature, a smaller median than the mean, shows that the data it has right skewed, and this SA features shows how stable the measurements are, where a low SE indicates consistency of cell size and high SE indicates heterogeneity for the sample. And the last is the worst features. These features give insight into the worst case scenario, where most features have a median smaller than the mean, which indicate a right skewed distribution, except for the radius and texture features, which are symmetrical. And the combination of the worst mean and SE values of this variable help predict breast cancer by providing valuable information about its malignancy rate. Next.
It is also important to look the proportion of breast cancer diagnosis. Here we show the proportion of the diagnosis where it can be seen that the data mostly consists of benign cancer, which is 62.7% of the total the data, while 37.3% of the data is malignant cancer. That this indicates that the data is unbalanced. Based on the data distribution, benign cancer is mostly concentrated at low values, while malignant cancer shows a wider spread with many high values, especially in worst case, where the mean and worst case values for malignant diagnosis are higher than those for benign diagnosis. We also displayed a heat map to visualize the correlation between features, where the darker colors indicate stronger correlation. Next, We performed for the feature selection using elastic net by eliminating features with a coefficient of 0 and reducing multicollinearity. The elastic net method is used because the dataset consists of 32 variables that are indicate to multicollinearity. It is expected that this method can improve the accuracy and generalization of breast cancer diagnosis prediction. With an alpha value of 0.1, we selected 16 variables achieving an excellent accuracy of 96.49%. This is for the variable based parameter feature selection and confusion matrix, and this for the insights.
Okay, we also perform feature extraction using PCA and obtain PCA standard deviations whose value is more than 1, as many as 3 with PCA scores as follows. Okay, it is also important to note that in this study, we use k-fold validation and repeated holdout with k equal to 10, which means the data is divided into 10 parts, and in k-fold, the model is trained 10 times, which each part used as the test data once, and in repeated holdout, the data is split into 2 parts, which is for training and testing, and repeated 10 times to ensure more reliable results.
Now let's move on to the first machine learning model, which is support vector machine or SVM. We perform the tuning parameters to determine the base parameters using C equal to 10, scale for gamma, and linear for kernel. The SVM model achieved a good accuracy of 97.9%. We also displayed the ROC curve as shown below. Next, we compare the validation techniques for the SVM model using k-fold CP and repeated holdout, and found that repeated holdout provide better validation with an accuracy of 96.58%. And this is for the model validation. Next.
Okay, for the second machine learning model is random forest. We also tuning it to determine the best parameters, and we use parameter 3 for maximum features, 2 minimum sample lift, 2 minimum sample split, and an estimator equal to 50. And the random forest model achieved a good accuracy of 97.37%, and we also present the confusion matrix and also our C curve below. Next, we compared the validation techniques for the random forest model using cable CV and repeated holdout and found that the repeated holdout provided better validation with an accuracy 96.47%. And this is the model validation.
Okay, we compare the SPM and random forest models based on their evaluation metrics. Based on the evaluation results, SVM outperformed random forest with higher accuracy with 97.9% and AUC for 98.81%. This shown that SVM is more effective in distinguishing classes and avoiding misclassification. So SVM is a better classification model in this case. The classification characteristics results are very similar to the original characteristics, so that it can be concluded that the classification method used is very good at classifying at diagnosis of benign cancer and malignant cancer in breast cancer data.
Well, everyone, from the analysis below, it can conclude that a better model for classifying breast cancer data is SVM for classification with the accuracy rate of 97.9%. And we also found that the better validation technique is repeated holdout with k equal to 10. And for improve the model's performance, we can try other methods like logistic regression, neural networks, and naive Bayes to boost accuracy. Using a larger dataset, it also can help the model generalize better. Adding new features related to the breast cancer might also increase accuracy. And last, applying advanced technique like random search can help find the best settings for the model. These tips aim to make the predictions more reliable and effective. Okay, That's all for our presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.